So what are the countermeasures against all of these attacks? Let's go take a look. You need to make sure that you choose the proper encoding scheme. Now again, involve your web app developer. So there are encoding schemes for URLs, HTML, Unicode, base 64. Now base 64, in case you forget, instead of having 8 bits for a character, it's 6 bits. So the words look very different. But all you have to do is kind of rearrange that. And so it's an obfuscation. It's not really encryption in any way. But there's base 64 encoding and there's hexadecimal encoding. So there are encoding schemes. Choose the right one. Use the right one appropriately. Defend against those SQL injection attacks. Put limits on the length of user input. Ensure all database traffic is monitored. Ensure the use of custom error messages. Don't let SQL use operating system commands such as XP_command shell, which is a Microsoft extended procedure that allows SQL to run operating system DOS commands at the command prompt. Set the method attribute to post to use low-level privilege or low privilege accounts for the connection. Make sure that the database and the web server are isolated from each other. Ensure minimal writes on the database server. Store the extended procedures, which are basically the things that are the most powerful, on an isolated server. Well, that's going to be interesting, grabbing them all the time. Have all user inputs be validated and sanitized. And ensure the use of type-safe variables and functions. And again, this is stuff that you need to tell developers to do. They should know what that is, or they should know how to look it up, or you can point them to OWASP.org. To defend against command injection flaws, make sure that input is validated. Ensure escape from dangerous characters. And you can have your, escaping a dangerous character depends upon the version of SQL and the type of language you're using. So have your developer look up what are the dangerous characters and escape. In other words, don't process them. Just treat them as text. Don't treat them as anything special. Encode your input and output. Make sure you're using language-specific libraries. A library is just pre-written code that you can just reuse. Make sure you have safe APIs, application programming interfaces. Remember, an API is simply it's a programming feature. I have some little programming object, a little block of code. It does 3 things. Maybe it's a little dog application. It barks, it sits up, and it wags its tail. And then I have another little application that wants the dog to do something. This app doesn't need to know how the dog does anything. It just needs to know if I want it to sit up, push this button, or in other words, make a function call to this, and the app will do it without any knowledge of anything on the inside. It is a whole discipline in coding to make sure that these little APIs, which are basically push buttons, really is what they are. They're kind of like the buttons on a TV remote in terms of their how you can't see what's going on inside, and you shouldn't. There are whole disciplines on how to do that safely and securely. So you need to make sure that your app developer does that, or that they quickly learn how to. Make sure all request parameters are interpreted as data and not as commands. Ensure the use of modular shell disassociation. No launching shells, okay? Ensure the use of parameterized SQL queries. And when we talk about SQL, we'll see some examples. So how to defend against cross-site scripting? Well, again, validate all input against strict specifications, like somebody's first name should not be 200 characters long. Make sure you use testing tools during the design phase of the app. Use web app firewalls. There are plenty of third-party appliances that will examine web requests, and they'll know specifically to look for all these weird things. Put that in front of your web server. Ensure the conversion of non-alphanumeric characters, in other words, things that are not the alphabet or numbers. Make sure they convert to HTML characters. and they're not interpreted as something else. Websites with HTTPS cannot always be trusted in terms of cross-site scripting. Be sure to filter script output and put into place a standard of signing scripts with public and private keys. To defend against denial of service, make sure the firewall is configured to deny ICMP. Ensure that any remote administrative connectivity, you test it, it's secure. Don't allow the use of unnecessary functions. Ensure that input validation is executed. Make sure that sensitive information cannot be overwritten. Make sure that data processed by an attacker cannot be executed. Okay, this next page, show this to your web app developer, because they'll know how to implement this, or they'll know how to look it up and how to do it. So your WSDL access control permissions need to be configured to grant and deny access to WSDL-based SOAP messages. Make sure you have firewalls that filter SOAP and ISAPI. Make sure that you implement centralized inline requests and response, some kind of schema validation for that. Use SAML document-centric authentication credentials. Make sure that intrusion detection systems and firewalls are configured for signature detection and web service anomalies. Ensure external references, in other words, pointing to other things outside your own web server, are blocked, and that content is not fetched on the fly, it's pre-fetched. Make sure you use multiple security credentials. Use IDSs, firewalls, and filter improper XML and SOAP syntax. And ensure that the security repository of XML schemas is maintained and updated. Again, do not expect you to be a web app developer. Get your web app developer to look at this list. To secure CAPTCHAs, make sure that clients don't have direct access to the CAPTCHA solution, obviously. Do not reuse CAPTCHAs. Make sure that you randomly switch between CAPTCHAs and randomly distort the CAPTCHA image so that there's no reuse. Make sure you use well-established CAPTCHA implementations and permit users to use audio. Make sure that individual letters are warped so that you can't have like optical character recognition recognizing what they are. Ensure letters in security code are random. Make sure communication between the website and the CAPTCHA system is encrypted. And ensure the use of multiple fonts in CAPTCHAs. Additional countermeasures. Make sure that you do not have any of these things going on. No unvalidated redirects, no broken authentication or broken session management, no cross-site request forgeries, no insecure cryptographic storage, no insufficient transport layer protection, no directory traversal, no cookie or session poisoning, no security misconfigurations, no LDAP injection attacks, no file injection attacks. And those are the countermeasures that should be considered when these web apps are being developed.